Okay. Good afternoon, everybody. I'm on mute. Hello, good afternoon, everybody. My name is An Nguyen. I am a professor of journalism here and a director of the Center for Science, Health, and Data Communication Research here. I'm very delighted to welcome everybody to this hybrid talk with by Professor Bodo Winter. He looks very young, but he's a professor from University of Birmingham. Bodo is a UKRI Future Leaders Fellow, getting in a big grant, 1.1 million to do research into how we communicate numbers, how to make numbers meaningful. And he's going to study it for another 3 years. And I'm a big fan of his stuff. I've read quite a bit of his stuff, but it's really great. So I'm very pleased to welcome Bodo and welcome everybody in the room and everybody online. Floor is yours, Bodo.
Perfect, thank you. And let me start with a thank you to you for inviting me here, and also thanks for everybody for being here today. So what I wanted to do in this talk is to give a sort of high-level overview of the research that we've been doing that's looking at numerical, the communication of numerical information across different modalities. And it's a pretty big project, so there are a lot of things to talk about. So what I will do is I'll do sort of a show reel of the various things that we have looked at, so that we can also create some common ground for the grant application that we had in mind. So to just start by some thank yous to the fantastic team. They're now not the team anymore, but that was really one of the amazing things with this Making Numbers Meaningful project, having a team of researchers who are all excited about numerical communication and improving it. And so everything I'll be presenting is work that's been done together as a team. And to frame things, what's really the big picture perspective of this project is that we want to look at numerical communication that is often studied in a sort of more siloed way, where, for example, there's a huge literature on data visualization, and there are conferences where people present experiments about which graphs are comprehended better or worse. But at these conferences, if you go to one of them, it feels as if graphs are sort of living in a void, and there's no language surrounding them that frames or talks about the graph. And so what we wanted to do is actually take a more holistic perspective, where we're looking at, for example, how graphs are embedded with language, how numbers are used together with gestures even. I'll give you some examples of that in a second. So really look at the whole gamut of what are the different linguistic ways through which we communicate numbers. And I'll talk about all of these as we go along. But the idea is not to just look at what is being communicated, so specifically through corpus analysis, so where we look at naturally occurring language, but also then how do the different communicative strategies impact decision makers? So how does, for example, can gesture influence what number you have in mind, and can it sway your opinion on certain topics? And so in the project, there's a bit of a, this is gonna be a bit of a problem, but it's okay. We both do a production, focus on production, which is mostly corpus analysis, and then the reception stuff is mostly experimental. So where we then do experiments that are informed by the corpus research, developing stimuli that look like the naturally occurring numerical communication, and then test how that influences decision makers or understanders. So let me just walk you through these different strategies that I have here on the slide to give you some examples, so that we get a feel for the variety of different ways through which the same numerical fact can be communicated. So this is really, let me see whether I can put this somewhere else, or maybe, well, who cares about the references? Okay, there, perfect. That's one less. And then let's put this over here let's put this over here, and let's put this over here. Okay, that should be better. Okay, perfect. Okay. So when we talk about numerical communication, probably the first thing that comes to mind is actual numbers that are being communicated. So expressions like 32 units were recovered, or there were 500 people at the protest. And that affords exactness, but as I'll show you, we have some studies which show that actually the exciting thing about numbers is how inexact they're used most of the time. Then we can communicate the same information either by a number or, for example, with a graph. So here I have a number of people at a protest in two different locations in Birmingham. And a graph gives you less detail because you're less likely to look at the exact values, but it communicates a lot of information at an instant, at a glance. And so it's really good for comparisons of numerical information. Then we have quantifiers, and this is something that linguists get very excited about. So there's a lot of expressions like many, the majority of several, that allow you to express the same thing, but in a purely approximate way. What is many is not so clear, and it actually differs between different people. Or only a few showed up at the afters. So these types of expressions are called quantifiers. A very dominant but very understudied, I'd say, is spatial language that is also being used to refer to numerical information. So this seems very standard to us, but the word large originally was used to only refer to a spatial context, and now we're co-opting spatial vocabulary to use it in a quantitative domain. So there was a large number of people at the protest. It's a high number. It's rising prices. His score plummeted, where we either use size-based vocabulary or vertical vocabulary to talk about numerical quantities. And a lot of this language is also actually quite vague. So what is a high number is, again, open to a lot of judgment. And then finally, we have gestures. And that's probably the last thing you think about when you think about numbers. But actually, as I'll show you, they're very important because when politicians talk about numerical facts, they will also gesture. It's very hard not to gesture while you talk. And when people talk about numbers, they gesture a lot. And so I'm going to give you an example from our earlier research. This is a qualitative analysis of specific instances of people talking about numerical facts to just get a sense for how gesture might play a role here. So this is one example that we discuss in the paper, and I'm going to play it.
5 million people, 175 million people on the thing now, adding a huge number of users every day. 6 billion people on the planet. Probably 3 billion of them with kind of modern grid electricity and maybe telephones. So maybe the total addressable market today is 3 billion people. 175 million to 3 billion is a big challenge.
So that's a beautiful little excerpt that shows you a lot of gestures, a lot of which are related to quantity. And what's interesting about it is that you have different quantities being mapped to different aspects of the space. You have 3 million versus 6 million. And then at the end, you have also a left to right mapping, sort of going along the mental number line from this is the first amount of users, and then the bigger amount of users is on the right-hand side of the speaker. As you can see, as somebody's talking about, in this case, users on Facebook, I think is the context, people are mapping out the quantities that they're talking about in the space in front of them. And I'll give you another example of this. So this is from...
The first poll put him at 2.8% support. Even my candidates had higher numbers than that. Okay? See what I'm saying?
So I'll play it one more time because the beginning is a bit hard to miss.
The first poll put him at 2.8% support. Even my candidates had higher numbers than that. Okay? See what I'm saying?
So what's interesting about this example is that you can see different spatial mappings being combined as well. So the left hand being used in a precision grip to sort of signal a small quantity, and I'll show you that this is something that speakers do much more commonly. It's not just this one example. So he's using the left side with a small quantity, and then he switches to a vertical format where he then talks about a higher number than that and actually maps out a contrast on a spatial axis. So that just gives you a flavor of why gestures might be relevant. But really, what's exciting to me is that there's this semiotic diversity, these different ways of making meaning that are all being combined. So you will be hard pressed to find a presentation where there isn't language together with a graph, together with a gesture. When somebody gives a presentation, they combine all of these. And so this is very much in line with, in linguistics, there's more and more people thinking about language as fundamentally multimodal. And what the project wants to do is to make a pitch that this is also relevant in the numerical domain. So this is actually a recent position paper that's called simply Multimodality Matters in Numerical Communication, together with my friend Tyler. And what we wanted to make in this paper is we wanted to make a case for the fact that, yes, it is important to pay attention to this, but also systematize or think about what are the different ways in which the modalities matter and how do they differ from each other. In the paper, we point out that there are different commonalities across these different modalities when it comes to presenting numerical information, as well as differences. So each one of these modalities has different communicative affordances. And then importantly, the modalities also interact with each other. They don't stand alone, but they work together as a package. So just to walk you through this table, the sort of main points, all modalities afford exact versus approximate expression. So that's a sort of important baseline. At least in principle, they afford you can express something exactly. So even in gesture, you can do that. That's an exact one. But most of the time, we would probably use gestures that are inexact. But in numbers as well, you can use them exactly, or you can use a round number approximately. Every one of each one of those can do both. A question will be to what extent maybe all of them are more biased towards the approximate side. And that will be my main claim at the end of this talk. Another interesting thing is that across these modalities, and this is also why they are worthy of being studied together, they seem to reflect shared cognitive mapping. So you find the same cognitive principles in different modalities. So to give you an example of this, we know from the literature of numerical cognition, so this is in cognitive psychology and experimental psychology, there's dozens of experiments that look at whether we think about numbers spatially. And so in one standard task, you might have to say whether numbers even or odd, and you have to press a button. And the even or odd buttons are aligned vertically. And it turns out that you're faster to respond to a relatively larger number if the button is also an up button. You're faster with a relatively smaller number if it's the lower of the two buttons. And that suggests that there's a very automatic cognitive association, in this case, between vertical space and between quantity. That's evidenced by these experiments. Now, what's interesting then is that these experiments they happen in the lab and people just look at these numbers. They're very removed from numerical communication, but you can actually see this vertical mapping in communication as well. So in spatial language, where we talk about high and low numbers, in graphs, which are vertically oriented with higher quantities going up, as well as in gesture, where people talk about higher numbers than that, as we've just seen. So it's the same higher quantities go up that is reflected in different modalities. Shared semiotic principles. This is, you know what, I'm going to skip this because it's, you can read the paper for this. It's not as relevant for this talk. And I'm also going to skip this. So other differences, but one that I want to highlight is reliance on expertise. So for example, graphs, there's people talk about graphicacy, like not everybody, we cannot assume that everybody understands graphs the same way. And it actually requires a lot of knowledge to understand a graph compared to, for example, a gesture, which would be much more commonplace. So whether the modality requires more or less expertise is one of the dimensions of difference. One of the most interesting ones to me, and also because specifically for gesture, is the dimension of plausible deniability. So gesture is interesting because we know that gesture influences how you perceive something, but you are often unaware of the fact that you have been influenced by gesture. So in forensic psychology, there's a big literature on the so-called gestural misinformation effect, where if you, for example, ask a question about an eyewitness testimony and you ask what gun, what was the weapon that was used, and you prime people with this gesture, they're actually likely to report that they have seen a gun in a video, even though there wasn't a gun in the video. And that's something that completely passes through the sort of threshold of awareness. And it's also interesting because when you think about political discourse or how we hold people accountable, politicians are held accountable for essentially what's in the transcript, but not so much of what's in the gestures. But if you can show that the gestures actually matter, then maybe that is a dimension of accountability that we should also be paying attention to. In particular, if it can sort of covertly sway us. Okay, when it comes to the interactions, so there are different, we typologize the interactions between modalities like this. The most basic one is essentially you could talk about it as redundancy, where the different modalities express the same concept. But we like to say they're amplifying the same idea because they're actually complementary to each other. So if you have a graph that shows a quantity and you also have a number and you verbalize that in speech, then that's 3 different channels that express the same information. And those things actually amplify each other. They're also from the perspective that if, for example, your audience might not pay attention at a second, they might see one of them, but might not see the other. So the message is sort of more robustly encoded this way. Very importantly, one modality can direct attention to the other. And a skilled numerical communicator will talk up a graph and actually gesture at what they're currently talking about so that people actually can process the graph in a piecemeal fashion. So you can direct attention, if you have a complex graph and you don't know what you're looking at, you can direct your audience's attention with gesture. And then finally, it is possible for one modality to either explain what happens in another or even to completely reinterpret it. So for example, I might show you, I have an axis of socioeconomic status on the x-axis, and I frame that as wealth. And then I have life expectancy on the y-axis, and I frame that as health. So I sort of use language to frame the numerical information that's being displayed. And sometimes you can completely reinterpret it. So the same gesture could be a good upwards change or bad upwards change, depending on what language you use alongside with it. So that's just a way of sort of systematizing some of the thinking on multimodality in the context of numerical information. Okay. So I want to zoom into gestures, and then we'll talk about some of these other ones, and we'll end up with talking about numbers, the allegedly most precise one. But I want to sort of show you some of the work that we've done on gestures to really convince you that it's important to pay attention to this. So this is based on this paper led by our student, PhD student, and then at the postdoc later, Greg Wooden. Tiny numbers are actually tiny, where what we did is, rather than just looking at these specific instances in a lot of detail, what we wanted to see is, at large scale, how often do people actually gesture when they talk about numbers? And can we quantify this? And so what we're using here is we're using a data set that's called the TV News Archive. The TV News Archive makes all of American television available 24 hours after it's been aired, and it's captioned. So you can go online and the day after you've seen a show, and you type in the phrase that you've seen, and you will get exactly the video, but you also get all the other videos that use exactly that phrase. And what I'm going to show you is I'm going to show you 3 years of American television, specifically from 2009 to 2013, of people using the phrase tiny number. And I think we can see certain patterns here. Oops.
A tiny number.
Tiny number. Tiny numbers.
Tiny number.
Tiny number.
A tiny number.
Tiny number.
Tiny number.
Tiny number.
Tiny number. Tiny number. Tiny number of people.
Tiny number. Tiny numbers. Very, very small tiny number. A tiny, tiny number.
A tiny number of. A tiny number of.
A tiny number of.
Tiny number of
A very tiny number.
A tiny number of.
tiny numbers.
Tiny number.
Tiny numbers.
It's a tiny, tiny number.
Yeah, tiny number.
Tiny number.
So that's a sort of 3 years of American television from the perspective of this gesture. And it's just a nice demo to show what rich data source you can get from this. And you can do gesture research at a really big scale. So gesture research is often done in sort of small labs where you get a couple of people in and you get them to gesture. And that's cool. You get a lot of really important information from this, but this allows you to sort of look at hundreds of speakers and actually do generalizations across that. So just as a quick aside, in the top right, you will sometimes see these weird links. For everything, all the data and code is available. So if you download everything, it should reproduce on your computer. And actually, if you wanted to get, for example, some of the scripts that we use to scrape this data, it can also be used. So it's reproducible. What we did in this study is we looked at the expressions tiny number, small number, large number, and huge number, sampled 800 random videos of each one of them, which we had to manually annotate. Because what happens in this is that a lot of the times you don't see the speaker, a lot of the times the hands are occupied. There's a lot of reasons for why this data cannot be used for gesture analysis. So we actually, even though poor Greg had to watch 3,200 videos with a lot of Fox News, he only ended up with 681 usable videos in the end, where the speaker was actually visible. But it's still a lot. And actually, this is from 584 unique speakers. So very few people in this data set that are repeated. So Barack Obama, Donald Trump, people that you have multiple data points of. But this is nice because then we can really make generalizations across a lot of people in the TV news. And so what I'm going to show you is the dimensions for which we have annotated this data. So we've done inter-rater reliability checks. I'm going to gloss over a lot of the methodological detail about every individual study so that we can power through more of them. But the first thing we looked at is basically the handshake. So whether the handshake, no gesture, whether the handshake is a curved handshake, which is like this, or it's a closed hand, which we have any form of precision grip where the index finger and thumb are approaching each other, or like this, or an open hand like this. Yeah, that's what we're looking at here. And I'm going to show you the proportion with which these different types are used for tiny number. So here we have 166 videos. And the first thing to look in this graph is actually the black box, the no gesture box, which is that there's very few instances of people saying tiny number where they're not gesturing. The majority of the time they are gesturing and are using a closed hand, as we've seen in that video. With small number, you have already more open hands. With large number, you have even more open hands and even less of the precision grips. And then for huge number, that pattern is even more pronounced. You can see this nice sort of climb where like the hands sort of open as the quantities grow. But really, to me, the most striking thing is that this category, the no gesture category, is so infrequent. And using a round number here, but across the board, about 80% of the time that somebody used one of those 4 expressions, they also gestured. And this is politicians, TV news anchors. So it just gives us a baseline for, yes, this stuff is important. And even if you say, okay, this is TV news and maybe these people are trained and therefore are gesturing differently, it still is important because a lot of people will then see these. They have the potential of being influenced by these gestures. Okay. But this is a bit sort of gesture researchy, but we also looked at whether, if it's two-handed, whether the hands are close to each other within the torso, about torso height, or further away from each other. So you can either signal size like this, or you can signal it like this. There are different ways of communicating size through gesture. Tiny number, lots of narrow gestures, so within the torso. Small number, and then it shifts. And for huge number, you have relatively more of the wider ones that go outside of the torso. So we can see 2 different ways of communicating numbers here, either like this or like this. And then finally, if people are using 2 hands, they're often also doing these dynamic gestures. that are either inwards directed or outwards directed, so like huge number. There you find that for tiny number, there's relatively more inwards gestures, for small number as well, and then that's flips for large number and huge number. Yeah. Okay, so this is in many ways quite trivial, I would say, in the sense that we're just looking at the gestures that you kind of expect when people are using these expressions. But I think it's important to realize that this is, for one, allowing us to look at these spatial mappings that have been looked at in the numerical cognition literature and actually find independent evidence from a more ecologically valid context where people are actually using these spatial mappings that we know from experiments, but we see them reflected in gesture. And importantly, we see gesture being very frequent, and that's therefore something that we should pay attention to. But this is, of course, only production. So does the gesture actually change what you think about a number? So this is what we then explored in a follow-up study. This is a project led by our postdoc, Alexandra Lawson. And it's simply a proof of concept that the gestures that we've seen in the corpus analysis, whether those can actually have an impact on your interpretation. And what we did here is we looked at quantifiers. We didn't want to use tiny or huge number because if you, I'm going to forget this for a second. If you do, if you show somebody a video and they're saying a tiny number of people, or then you're saying a tiny number of people, that's really weird. You're creating a mismatch. So what we wanted is we wanted a vague stimulus in the language so that then the gesture carries more of the weight of communicating the numerical information, but also not creating this sort of weird conflict. So we looked at a study that has looked at how people, in this case, it's just looking at which quantifiers they use depending on how many circles there are in a box out of 400 circles. And this gives you, in this production data, several. Some people used it for 100 out of 400 boxes, but actually a couple of people used it for close to 390 out of 400 boxes. You can see these quantifiers are really vague because people accept a lot of different quantities with them. And we use this study from Bob Van Thiel and colleagues to pick several because it is the one with the biggest range as a starting point. Because we're thinking that if it is the most approximate, then maybe gesture can have a bigger role to play with this. We're actually currently already doing work with the entire set of quantifiers. But what I'm showing right now is just several. So it's just one quantifier, but the quantifier is a proof of concept. It's a really nice sort of fruit fly to look at the effect of gesture. And our stimuli are like this. So this is a colleague from our department who volunteered to create the videos. And there are things like 400 people were at the protest. Several of them got arrested. And then you are asked, guess how many of the 400 people got arrested? Please give a numerical value. Very simple task. And we have another model speaker in this. So we have both a female and a male video. And we have an outward gesture, a no gesture condition, and an inward gesture condition. And then we have 20 different contexts. So we don't have not just protests, but also 400 grants were given last year. Several of them were in the humanities. It was another stimulus. So we have all sorts of different contexts so that we can also generalize over the contexts. And we ran this study with 600 English speakers on Prolific, a crowdsourcing webpage. And what I'm going to show you is we are modeling whether what is the quantity as a function of the gesture. So what you're seeing here is the averages, the average numbers for the 3 different gesture conditions. And this gives you a range of certainty, like the average could have also been different. So I'm skipping over a lot of the stats that you don't even see. But anyway, what we see in this graph is we see a really nice effect where both the inward gesture and the outward gesture are pulling estimates in away from the no gesture condition. And by a fair bit. So if you have the inward gesture, your estimate was on average around 60 people went to the protest. If it was the outward gesture, 150 people went to the protests, and that's a massive difference. So it has a real effect on this. And we then replicated the study twice, where we also, in this study, you only see one stimulus, but it also works if you're seeing multiple stimuli. So it also works within subjects as well as between subjects. Okay, what was really cool though, is because we have so many different stimuli, and our speakers are humans in these videos, they have natural variation in the size of their gestures. And we can exploit that variation by measuring exactly how far are the hands away from each other and seeing whether that, in a continuous fashion, correlates with the predicted quantity. And indeed it does. So what you're seeing here is that as the distance, and we actually went to the videos and measured the pixel distance, as the hands are far further away, the predicted quantity continuously grows up. So it's really nice. It's not just a categorical inward-outward, but it's also these, like how far you're getting. Okay, so we've done this in this paper with several, and we're currently doing this with all of the quantifiers, which then becomes interesting because, of course, the inward and the outward gestures will produce potentially different effects depending on which end of the range they're at. And then we can test whether it's actually the case, whether the more approximate quantifiers are actually the ones that are more susceptible to gesture. Once we're testing multiple quantifiers, that's something that we can then test. So stay tuned for more on this. Okay, cool. But that's just showing us that gesture matters. And we have both the corpus analysis and the experiment to show that that's the case. We're now going to zoom into the spatial language. And there we're currently doing a project on how people talk about changing quantities. So rising COVID cases or falling, plummeting salaries. So these sorts of expressions where we use spatial language to talk about numerical change. So we're going to zoom into these types of expressions where we use verbs to talk about changing quantities. And some important background here, and this was actually one of our research questions. We know from linguistic work on how these words are used concretely to talk about physical change. So rising water levels or rising to the top of a mountain, that in general, movement language in English in particular has a goal bias. So we talk more about the end point of a movement rather than the beginning of a movement. To give you an example of this, I climbed from my room down to the window onto the roof, is an example discussed in this paper. You can also say I climbed onto the roof, but it sounds a bit weird to say I climbed from my room. So if you're only expressing the source, that seems ill-formed in this case. And that's not just this one example. People have done corpus or studies where people look at motion events on the screen and then they have to describe it. And a finding again and again, both with adults and children, is that they are more likely to mention the goal of a movement, the endpoint, rather than the beginning. And this is even the case in pre-verbal infants. So if you look at motion events, infants will preferentially look at the endpoint of a movement or the endpoint of a trajectory rather than at the beginning. So there seems to be some very basic cognitive bias that makes us sort of goal-oriented. And the question then is, if this is the case with the motion language, if the same motion verbs are now used in the quantitative domain, will they also have this goal bias? So what we looked at is increase and decrease, and we went to an online thesaurus to get the highest ranking synonyms of those. So we have 16 verbs, increase and decrease arguably being not so spatial. But then we have grow, rise, go up, escalate, expand, extend, lessen, lower, reduce, drop, fall, decline, shrink, and contract. And we're looking at this in 4 different corpora: the corpus of contemporary American English, the British National Corpus. So these are 2 large reference corpora that are supposed to reflect general American English and general British English. And then we're thinking, let's also add 2 corpora where we expect more numbers and more numerical discourse. So the Jena corpus of corporate annual reports, is freely available. So we use that as the third corpus, and then the COVID corpus, which is a collection of newspaper articles that mention COVID in them. We're looking, we're sampling equally across these 4 different corpora. And so we have 16 verbs, 4 different corporas, and for each one, we're looking at 100 concordances. 100 lines of text, which we're going to analyze for whether, for example, the goal is mentioned or not. And that gives us 6,400 concordances to annotate, which was a lot of work for our research assistant Tortoise. But she had a lot of fun with it, she says. Here's an example from this corpus. Since World War II, births outside marriage have increased by 5 times as a percentage of all births in the United Kingdom, from 5% to 25%. So what we're annotating is we're annotating the different components of the change trajectory. Yeah. So by 5 times as a percentage of all births in the United Kingdom is an expression of the magnitude of the change. That is the equivalent of you're walking along something. So that's the middle point of the trajectory. Then we have the source, in this case, from 5%. And then we have the target, in this case, to 25%. So we're annotating that for each of these expressions. Then we are looking at the quantity, and we're actually also, there are different types of quantities, of course, that are being discussed. And that was actually the hardest bit, because we had to revise our annotation system 1,000 times, because there's no set way, there's no typology of all the quantities. And it's really hard to make a decision about what is really quantitative. So, for example, when you're talking about my anxiety levels are rising, is that quantitative or is it not quantitative? We have lumped a lot of this together into a bit of a cover category, amount/intensity, which is any reference to an amount or an intensity. So that covers things like my anxiety levels rising. But also cardinal numbers, precise, countable numbers, proportion shares, durations, risks, chances, physical magnitudes and physical location. And that's really the important bit. We want to separate these users from these users, the ones that are more numerical from the ones that are more concrete. And we didn't want to classify, so I said to you that we use both size-based and vertical language to talk about quantity. But we didn't want to make that decision because, for example, to grow, is that really size-based, or is that because if you're growing up and you're also growing this way? So what we did is to, as a baseline for these verbs, so that we can look at whether maybe the size-based verbs behave differently from the vertical ones in, for example, whether they mention the goal. What we wanted to do is we wanted to norm the verbs for whether they are more size-based or more vertical based. So you have a slider where you can say it's more like this or it's more like this. So we did that with 50 English speakers on Prolific to basically have a measure of how much each verb is size-based or vertical. So here are the verbs again, and here you see the results of this norming study, where this is from the size side of the slider to the vertical side of the slider. And you can see then that contract and expand and extend are really size-based, and these ones are really vertical. So for the purposes of talking about these results, it's going to be easier if we're going to treat these 4 as categorically size-based, these ones as not having any specific bias as much, and these ones as vertical ones. So I'm not usually a fan of categorizing a continuum, but this works really well for presenting this data. Okay, so let's look at some preliminary results. I say preliminary. This is based on 1,500 concordances, so 25% of the data. She has now annotated the entire data, and I've had a look at this, but I haven't had the chance to update the graphs. They don't actually look that different. So it seems that the basic patterns we are already finding with the subset of the data. Okay, so first, just to see what are the most likely ways these verbs are used, is the amount intensity expression is the most common one. And I think this is partially a reflection of the fact that it is a sort of cover category in our annotation system. But what I think is interesting about this is that this category which is clearly non-physical and not concrete. It's always about some abstract amount or some abstract intensity, that these verbs like rise or grow are actually more often used across these 4 different corpora in a way that is non-physical. So they come from a physical meaning, but here it really shows that they are used in a quantitative way a lot. But what's more interesting with respect to the question whether this goal bias also exists here is whether the source was mentioned, or the magnitude, or the target, or any combination of those, because each one of them is optional. And I'm lumping together all of the quantitative uses, so that's everything that's not the physical location, and the non-quantitative is the physical location and the physical size. So only the physical concrete uses are in there. Because then we can compare the goal bias across the motion language, or the physical language, and the abstract language. And the most striking thing is that most of the time nobody mentions where a quantity has changed from, or where it's going, or how much it's changed at all. So you can see here that 70% of the time that somebody talks about changing quantities, they're not mentioning anything about how much that has been changed. It's just, does it go up or does it go down? And that seems to be the thing that is most relevant to the speakers. Then with respect to the other categories, you can see here that what's specifically of interest with respect to this goal bias is, yeah, all of these are very infrequent. Most of the time people just talk about that there is change, that it goes up or down, but not by not encoding any of these. But we can see that relatively speaking, the target is much more common than the source. So here too, we find this goal bias. People talk about where the quantity is changing to rather than where it has changed from. And the other interesting thing about this is that you can see these 2 bars of being similar heights across all of them. And if you actually correlate these percentages with each other, so from the quantitative to the quantitative, they're very highly correlated, which suggests that basically it's in these verb semantics already. And in the quantitative discourse, we therefore inherit the goal bias that comes already from the more basic motion use. But keep this in mind as we're talking about how vague and approximate most of numerical discourse is. This is one reflection of this, how little is actually encoded when people talk about changing quantities. Okay, now what's interesting then is that the size-based and the vertical verbs differ with respect to how much they're likely to encode this precise endpoint. So here I'm showing you for each one of these dots is a verb. So for example, this one here is the verb shrink. It has 0% time a source. And so that's why it's over here. And you can see that all of them are scrunched to the left because most of them don't occur together with sources. Magnitudes, you can then see that there's quite big differences between verbs. So for example, when you're talking about falling quantities, you're talking more often, a third of the time, by how much they have fallen. But there are these really interesting sort of verb-specific patterns. And then target, you can see that overall the distribution is more to the right. And for example, dropping 50% of the time was mentioned with an endpoint. And here you can see then this pattern where like all of the verbs are a little bit more to the right for the targets and much more scrunched together for the sources, but important variation between verbs. Now the question is, how much of this variation is conditioned by the verb being sized or vertical? So that's what I'm showing you here. So it's the same distribution. So we see around 10% of the time, the vertical ones mention the source, and the increase and decrease ones, and then the size-based ones, so grow, shrink, contract, they are the ones that basically have a sort of strong preference for being used with a specific source. With magnitudes, you find a similar pattern where, again, the vertical ones are more likely to mention by how much something has changed. And then with the targets, you find that pattern even more pronounced. So if you compare the vertical ones to the size-based ones, you can see then that the vertical verbs are the ones that are more likely to mention the target as well. And so if you look at this pattern within each of them, you can see that the size-based language is generally a bit more sort of approximate or used for just sort of talking about general changes, and the vertical language is used in a slightly more precise way, or at least encodes these points a bit more often. Another way of looking at this is if you're looking inside the expression, so the goal is being mentioned, does it also mention a number? So how precise is it? You could say it has risen to new levels, which mentions the goal, but it doesn't mention a precise goal. But it has risen to 50% is a precise goal. And what you see there is a similar pattern where the vertical verbs the goal expressions tend to be more likely to contain a number. And if it's a size-based verb, you're not actually numerically specifying it as much. For a reason that we don't understand quite yet, that pattern is reversed for the magnitude. So there, people are talking quite a lot with size-based language by how much something has changed in a precise way. But we find the same thing again for the endpoints the difference between vertical ones being more precise or more numerical in this way. Yeah.
10 minutes.
Oh, 10 minutes. Oh, gosh. Wow.
Maybe some time for discussion.
Yeah. Oh, wow. Yeah. Okay, cool. So I'm going to skip this then. So we're looking at, there's these other categories. They also have interesting preferences. But what I want to highlight here is this interesting division of labor that comes from this analysis, where the vertical language, which of course maps things onto a path, and a path has more clearly defined starting and endpoints conceptually, like for example a ruler, where you can then this path schema, so to say, this spatial schema affords more precision, and that's why the vertical verbs are used this way, because you have a clearly defined endpoint. With size, that's not so easy, and this is backed up by some research actually in graph perception, where we know that for when people look at size on graphs, they are more inaccurate determining quantities based on, for example, a pie chart, which uses size as a mapping, than they are when they see a bar chart. And so this has been long since known in data visualization research, but here we can see that the verbs behave similarly to this finding that we also have in data vis research. So the vertical axis affording more precision in this case. Okay, cool. Gonna skip this. Numbers. We need to leave some time for question. That's such a pity. I'm going to. There was so much that I wanted to talk about. Okay, I'm going to briefly talk. Yeah. No, I think I'm gonna, because I'm gonna, this is gonna be so much data. Yes, that is a lot of data.
3 hours.
Okay, yes. So I guess the one thing that I will mention of this research, which I'm currently most excited about, is we know from the literature on numerical cognition that larger magnitudes are represented in your mind more approximately. So this is an image of how in numerical cognition research people think about your representation of a number. So we don't actually have these we use exact numbers in language, but our representation of a number has a bit of slack surrounding it, and the slack increases with bigger magnitudes. And this is backed up by a lot of experimental research. So for example, how accurate you are at estimating quantities, this accuracy, of course, goes down at larger magnitudes. And so this approximate number system that is supposed to be where our number sense is coming from, we see reflected in how round numbers are being used, specifically at higher magnitudes. And what we show in this analysis, using data from the entire BNC, every single number in it. So we passed every single number in the corpus and pulled it out. That's 1.75 million numbers. We're looking at the magnitude as a function of rounding. And in this research, what we're doing is we are splitting up roundedness into different factors, because what is a round number is actually not so straightforward. So for example, the number 10,000 is much rounder than, let's say, the number 450, which could also be a round number. And so we show that these coefficients here, if they're to the right, it means that number is more frequent. And what this shows is that these are all interaction terms. So if a number is large and it is also round, it is then more likely to be frequent. So you can therefore show that rounding is actually more frequent at higher magnitudes, just as you would expect from the approximate number system. Okay, oh, these beautiful words. Okay, so let me then, to zoom out then, and to wrap up, we have what I like. So if you think about words like umpteen and zillion, which linguists call indefinite hyperbolic numerals, it's a bit of a weird word. If you think about these numbers, the number words, they only make sense. To me, they're the epitome of this approximate numerical discourse. These numbers only make sense in a culture that cares a lot about numbers, but not about precision. So, you know, we live in a culture where everything has to be backed up by data, but we have these mock numbers to just basically say it's really big from my perspective. And what we show in our corpus analysis is that words like thousand, million, and billion in particular behave very similarly to umpteen and a zillion. So this is an analysis that I won't be able to get into, but we're basically having a semantic map of the numbers. Show is that umpteen, zillion, and gazillion, these mock numbers, are very similar in semantic space to billion and million. And thousand and hundred are a little bit further away from them, and they're probably used a little bit more precisely. And so what this shows is that we use words like billion and million actually like zillion and umpteen. We often use them in contexts where we don't actually mean a billion at all. And that's evidence that these basic number words are really approximate to the core. Okay. Jigsaw puzzles. Okay, so my point then is that our research on numbers that have raced through has shown that round numbers are overrepresented, especially at high magnitudes, and a lot of the number words behave like indefinite hyperbolic numerals, so they're used very approximately. Graphs afford precision, but most of the time we don't use them this. Nobody reads off the actual numbers. We just get the numerical gist from a graph. So we think of graphs as precise, but we don't actually use them this way. Quantifiers are, of course, intrinsically approximate. Spatial language is approximate, and the gestures are most of the time approximate. So a lot of the different ways for which we communicate are based intrinsically approximate. And then on top of this, you have all sorts of ways of making numbers even more approximate. So you have all sorts of numerical hedge words that are used. And when a linguist sees a domain in which there's many different lexical items, that is often a reflection of communicative need. Why would there be so many words, so many different ways of expressing vague information if we cared about precision? Really. The lexical differentiation here, I would argue, reflects the fact that most of the time that we communicate numerical information, we don't actually communicate anything exact, but really just whether it's large or big from my perspective. Okay. So that's a sort of very quick roller coaster tour through aspects of our project. And I just wanted to say that on the impact side, on the applied side, we're currently working on a massive online course. It is going to be hosted on Udemy, where we're basically, this is a communicating data for professionals and academics, with the target audience being data scientists. And basically talking about what are the different, what can you learn from the cognitive science and linguistic and communication research about becoming an efficient communicator. So we're basically putting this research into best practice recommendations. Okay, thank you.
Thanks, Bodo. That's fascinating. Okay. I don't think we have a lot of time for. Maybe we have time for one or two questions. Anybody, maybe online first? Anyone? Or in the room? Yep. Darren first. Okay.
I wondered if you've done or you're trying to look at the persuasiveness of believability. Because while I was looking at thinking, particularly so there's approximations, all that kind of thing, are they also used, to convince people? The heads words, the approximation, like numbers of the protest, they can often be contested.
Yeah.
And how are certain words and devices that accompany about 400 or thousands and thousands of people, those kinds of things, how much do they persuade people that one side is so the metropolitan police cannot an exact number.
Yeah.
But for the protest organisers say thousands, do people believe the thousands?
Yeah.
And that's obviously not control of the group. But
yeah, that's really cool. So I mean, that's not a dimension which we have looked at. So we're really more focused on the is it understood, or what is being understood, or in this case, what is the number that they have in mind after hearing that? Much more on this sort of lower level rather than on the what are the social consequences of so for example whether maybe precision. So I mean I'm quite heavy on the approximation side also when it comes to like my own numerical communication because I want to increase the fluency with respect to my audience. But you're right, which is that of course there's a social dimension to exactness where it says something about your believability or whether you can trust that information. That's a dimension that in this project we haven't gotten at all. But I think that would be really cool to do because once you have sort of looked at the dimensions of approximation, you can then look at how that influences sort of downstream social effects. Yeah.
So fascinating.
Okay, cool.
Really super interesting. I was mostly interested to the gesticulation, and you were using a lot of hand gestures.
Yes, I mean, so yeah.
Right. Just a quick question. In your research for that part, did you include? Well, did you look at neurotypical and non-neurotypical? Because gesticulation has been muchly debated and has there's a lot of literature around ASD, for example, and gesticulation. So one of the ASD screening tools they use is how people process gestures and how they use hand gestures. And there's a growing body of study around gesticulations for adults with ASD disorders. I didn't know if that was included in that, and you saw any differences with that.
No, that was not included because that information unfortunately is not available to us when we're doing this sort of large scale research with the corpus analysis, because finding out for these 580 speakers that we had, which ones of those, and it's often not known. So I would presume that whatever we are showing here has the average levels of neurodivergence in the population, but who knows whether that's actually the case.
Yeah, and I saw the non-gestures as well, and I mean, we don't really know.
We don't know whether those might have been those that were
and not
exactly
our atypical or unatypical. I find it really interesting that some of the studies that have been done on this is adults with ASD, they process the gestures completely differently without them even realizing it. So I just wondered if that was something that you looked at in the literature.
No, not, but certainly something that would be interesting to look at.
And I know this because one of my friends did exam grade-offs. And gesticulation was taught massively as a screening method. And what they do with people with potentially ASD disorders, they ask them to talk about something numerically with or without their hand gestures and see how they do. And they sit on their hands. It's really it's really interesting.
Oh, that's cool. No, thank you. That's great. Yeah. Cool.
Okay. I think we might have another, but I have loads of questions, but I have to shut myself now. Okay.
I have questions I can ask afterwards.
Okay, cool.
Okay.
Let's go time.
Shall we wrap it up now?
I'm happy to wrap it up, or you can ask your question. I don't know.
Oh, you want to?
As you were talking now, I was looking at the showed you before the 17th century newspapers. And how they were using numbers. I sort of highlighted them before I came as part of the technical project, and I was looking at the different ways you could categorize it. And I was just wondering there's a lot of these quantifiers, multitude, severals, diverse, weirdly, which is like a word diverse used to be used for several, but then English language like diverse. So like
diverse, yeah, okay.
but there's also things like incredible or great. So like an incredible number of people or a great part of these. How does that fit into the spatial or the quantifiers when it feels more like a kind of use of don't know, like it's more descriptive language that doesn't necessarily fit into that.
It's like almost like incredible is interesting because it's definitely not really spatial. I mean the word itself isn't, but it seems to be a different category that we haven't looked at here, but it might be an interesting category to in a sort of typology. Where it's about your judgment, like it's about your reaction or what you think it is, how surprising it is, and that is then sort of metaphorically mapped onto the quantity. So those things we have not looked at, but that's because we are using the search terms, the spatial search terms to go into the corpus. We had the original vision of this project was to go through texts and annotate every single numerical expression. And then we found exactly this problem of the typology where we're just like, we don't even know how to annotate this because there's just so much variety of different expressions. And then they're also often nested comparisons. So like this number, which is larger than this, which from the before it was like this. And then you don't know how to actually annotate this. Ultimately, I would love this. I mean, ultimately, I've given you a pitch for approximation without actually, and I've shown you that there's a lot of approximation, but we've never really quantified what is the relation or the across an entire text of how much precision there is. And I think that would be really interesting to do. There's sort of like a vagueness fingerprint of the text, but based on every expression that occurs in there, rather than what we've done so far is to compartmentalize the topic by searching for specific issues.
Okay, cool. Thank you very much, Bodo. I wanted to ask the question, but anyway, I have to do school run now too. So, but thanks everybody, thanks everybody online and everybody in the room, and thanks to Bodo.
Thank you.
Hope you will come back here one more, many more times. Okay, okay. Thank you.
Thank you. And sorry if I missed time by talk.